Good afternoon, ladies and gentlemen. I am honored to have the opportunity to present our paper at this conference. My name is Luo Yan. Today, I would like to present our paper, A Context-Aware MAR-PAT Interaction Model to Enhance User Experience. In recent years, the development of mobile devices such as smartphones and tablet PCs made mobile augmented reality possible, which has been applied in various fields. Moreover, it has been proved that the emotional bonds between humans and pets will provide humans with physical, psychological, and social benefits. To leverage similar benefits of human-animal interaction, computer graphics representations of pets have been developed and widely applied. Compared to the conventional virtual pet, a MAR pet can provide users with stronger feelings of realism, relatedness, and psychological ownership, which indicates the unique advantage of MAR pet. Meanwhile, it allows users to create virtual pets anytime and anywhere via mobile devices without extra expenses. However, the issue of how to enhance the interactive experience in MAR pets has not been fully explored. Context-aware computing is a computing paradigm which allows applications to utilize contextual information and can help obtain a better understanding of the user experience. Therefore, this paper applies context awareness to MAR-PAT to enhance the user experience in such applications. Specifically, we propose a context-aware MAR-PAT interaction model to enhance user experience in MAR-PAT systems. To establish the interaction model, we define the concept of MAR-PAT as it's different from the ordinary virtual contents. Firstly, the prototype of MAR-PATs are animals which have the biological properties. Secondly, MAR-PATs have the domestic properties of pets, which means they have a series of features that are changed or acquired because of humans. Finally, MAR-PATs belong to the virtual world and are integrated to the MAR environment. Therefore, MAR-PATs have virtual properties, which means they have the characteristics beyond reality, and meanwhile are situated in and related to the virtuality-reality mix environment. This property allows us to relate MAR-PATs to the MAR environment through context awareness. Inspired by Chillet, who proposed the three important aspects of context, this paper redefines context and context awareness in MAR. For MAR, context refers to all the information that a mobile device can collect, including environment information, user information, and device information. Environment information refers to the information about the physical environment in which the user is located and can be divided into physical information and semantic information. Physical information refers to the physical properties of the environment, and semantic information refers to the content and meaning of the environment. User information refers to the user's physical state, physiological state, and consciousness state. The physical state includes the user's location, posture, movement, etc. The physiological state includes the user's gender, body type, appearance, etc. The consciousness state includes the user's emotion, intention, etc. Device information refers to the software and hardware state of the mobile devices, such as battery power, computing power, and sensor capability. In the case of sufficient device capability, the consideration of device information can be ignored. Therefore, this paper will mainly focus on the environment information and user information in context. For MAR, context awareness refers to the mobile device's ability to analyze and make decisions according to the context. Through the establishment of context awareness, mobile devices can analyze the information acquired by the sensors and guide the virtual content to make corresponding feedback to promise the consistency between the virtual world and the real world. The figure shows the framework of a MAR-PAT system based on context awareness. Model A depicts the usage scenario of MAR-PAT, where the virtual pet reacts according to the context. The user is immersed in the AR world and spontaneously performs interactive behaviors, such as crouching and reaching out to interact with the virtual pet. Model B depicts the relationship between the three elements in Model A, including the user, device, and environment. Model C describes a design model of context-aware MAR-PAT, which is presented with a simple iceberg model. In the interaction, the context-aware content presented by mobile devices is the part about the water surface of the iceberg, which is the explicit expression of MAR interaction. The context-aware design model is the part below the surface of the iceberg, which is the guidance and implicit support for the explicit content. Although it will not be directly expressed, it is of great significance. Based on the previous content, we propose a context-aware MAR-PAD interaction model. In the input stage, users can interact in various ways, which can influence the current context. In the context-aware stage, the device perceives and analyzes the context from the aspects of physical awareness, semantic awareness, and user awareness respectively, which is proposed based on the definition of context. In the output stage, the MAR-PAD gives feedback based on the results of context awareness by biological behavior, domestic behavior, and the MAR environment-based behavior, which correspond to the definition of MAR-PADs. Physical awareness refers to the fact that MAR-PADs are constrained by physical properties and influenced by the other physical entities in the real environment. For example, force interactions can be generated between MAR-PADs and real physical objects. Moreover, MAR-PADs have a reflection of the real light in the environment, and the virtual reflected light can be blocked by the real objects. Semantic awareness refers to that the existence of MAR-PADs conforms to the semantic information of the environment, and MAR-PADs can give relevant feedback according to the semantic information. User awareness refers to the ability of MAR-PADs to give feedback dynamically according to the user's physical, physiological, and conscious states. For example, MAR-PAD can understand gesture or voice command of users and can recognize different person by his appearance or voice. Moreover, it can perceive the user's emotion and give corresponding feedback. To evaluate the user experience from the bottom up in the user test, we propose a MAR-PAD user experience pyramid. Specifically, the model is divided into 3 layers, containing a total of 9 indicators. Layer 3 is the goal of the MAR experience, in which the indicators exist only for AR environment. The indicators in layers 1 and 2 exist not only for the AR environment, but also for the experience in real life. Layer 2 is the general goal of the MAR-PAD interaction experience, which is the focus of this paper, and Layer 1 is the highest goal of human-PAD interaction experience. Based on the context-aware MAR-PAD interaction model, we design and develop a system named Betty Dog, which enables users to interact with a MAR corgi dog called Betty. Functions are designed based on physical awareness, semantic awareness, and user awareness respectively. As for physical awareness, the brightness and hue of the virtual corgi change with the real light, and it can be occluded by real objects. Additionally, there are force interactions between the virtual corgi and real objects, and it will fall when colliding with real obstacles. As for semantic awareness, the virtual corgi appears in an ordinary room, which is reasonable. When the user gets the virtual corgi to move on a box, the virtual corgi will jump out of the box and walk to the target position. When the user holds the device near a plate at a distance, a virtual burger will appear on the plate, and the virtual corgi will walk up to it actively. As for user awareness, users can use hand gestures to interact with or give commands to the virtual corgi. Now let's watch a video of our results.
This is the screen recording of the mobile phone when running the system. First of all, recognizing the environment to identify horizontal and vertical planes. After that, the users can click the horizontal planes on the screen to create a MAR pet dog and make the dog move. Users can observe the occlusion between the virtual dog and a real box. When the virtual dog moves from point A to point B, it will be collided by the real box. When users ask the dog to move from point B to point C, the virtual dog can perceive the change of height and jump onto the box. Users can approach the plate with the device and a virtual burger will appear. Then the virtual dog will actively walk up to the food. Finally, user can interact with the virtual dog with hand gestures, include a stroke gesture, a sit-down gesture, and a stand-up gesture.
To verify the effectiveness of our model, an experiment is conducted to explore the impact of the three variables on user experience. The experiment is divided into 4 conditions and uses a between-subjects design. Group T1 is the experimental group, and the rest of the groups are the control groups, in which the variables are controlled respectively. By comparing Group T1 with the other 3 groups, the influence of the 3 independent variables of physical awareness, semantic awareness, and user awareness can be evaluated. We utilize a questionnaire in form of a 7-point Likert scale to collect subjects' responses from the participants, and the data of each indicator are visualized by box plots. We find that among groups with significant differences in each indicator, Group T1 gets the highest mean score, indicating that all the 3 independent variables of physical awareness, semantic awareness, and user awareness improve user experience to a certain extent, proving the effectiveness of CAPAT model. Through the physical awareness, user experience on indicators of presence, consistency, and attraction are significantly enhanced. Moreover, 72% of the users mentioned the phenomena that didn't comply with the physical laws. It can be inferred that the user's perception of physical laws is extremely sensitive. Subtle phenomena that violate physical laws can be easily captured by users and have a negative impact on their experience. Therefore, it is necessary to consider technical improvements to achieve more accurate and comprehensive physical awareness. Through semantic awareness, user experience has been significantly improved on the indicators of consistency and immersion. Meanwhile, users expressed strong desire for more interactions between the dog and the environment. Therefore, we can allow virtual pets have more diverse and borderless interactions with the real environment by comprehensively considering the available environmental factors and making them involved, as well as expanding the interactive space and designing richer interactions. Through user awareness, user experience has been significantly improved in 4 indicators of consistency, involvement, attraction, and immersion. In particular, user awareness shows extraordinary potential for enhancing involvement. It can be concluded that replacing indirect control of virtual content with direct perception of user behavior is an effective way to enhance user experience. Therefore, it is essential to improve the technology to achieve faster and more accurate natural interaction, and the designer needs to consider helping users overcome operational problems through adequate guidance. In conclusion, for MAR pet systems, we propose a context-aware MAR pet interaction model to enhance user experience. Additionally, a MAR pet user experience pyramid is presented to measure user experience from the bottom up in user test. Finally, we proved the effectiveness of the CAPAT model. In the future work, we plan to further improve the CAPAT model to establish the attachment between users and MAR pets more effectively. Moreover, we will increase the number and diversity of participants in user tests to cope with the multiple needs of different users and enhance the generalizability of the model. Meanwhile, we will also consider the technological factors in MAR to make mobile devices perceive the context more quickly and accurately. That's all of my presentation. Thank you for your attention. If you have any questions, please feel free to ask.